today we're going to talk about lesson 6.3. Okay, and so if you notice, we really don't have a lot of rest between now and the end of the semester, so we're going to go ahead and get going with lesson 6.3. And so if you look, first of all, we're going to talk today about arcs and angles. And so up here on the board, we're going to do these investigations together in class. So it's not going to be one where you're going to be doing them at your desk. And so if you notice here, it says to measure, that's what step one, COR with your protractor to find the measure of arc CR. Okay, so I've got a protractor here. Okay, we're going to go ahead and measure COR. So I'm going to go ahead and line up. Oh, that's close enough. Okay, we're going to go ahead and line that up, and we're going to see, oops, just how much COR measures. There we go. So, go back a little bit. So what does it look like COR measures? Here's 100. About what? 102. Okay, so we think it's going to be about 102. So what that means is that means that this angle here is 102. It also means that this arc here measures 102. Because if you remember, that was the definition of that intercepted arc. Okay, with the central angle, they have the same measure. So now what we want to do is we want to measure CAR. So if you notice, CAR is right there. Okay, that's called an inscribed angle because it's on the inside of the circle. Remember, we looked at those yesterday. So I'm going to go ahead and bring my protractor back here. I'm going to go ahead and, oops, this is the second, for some reason that row, and I can't get it to move. We'll try it again. There we go. So close. What does it look like? Okay, let's maybe move it over a little bit more. Well, we'll try that again. We'll try there we go. Okay, let's try to line that up a little bit better. What does it look like? It looks like it measures 51 degrees, okay? So now I know that this angle inside here measures 51 degrees. So I want you to compare the blue angle with the purple arc. What do you notice? It's half. Okay? So this blue angle is half the measure of the intercepted arc, and so that leads us to our first conjecture today. The measure of an angle inscribed in a circle is 1/2 the measure of the intercepted arc. So it's half of that given measure. Okay, I'll let you get that down, and then we'll look at our second thing today. Okay, so we're going to go ahead and move on with our second example. And notice here it says inscribed angles intercepting the same arc. So if you notice here, I have two arcs. So I'm looking first of all at arc P. So that would be this arc right here. Okay. Then I have arc Q. Arc Q is this angle right here. Now for those of you wondering, how does that happen? Well, because if I look here, here are the sides of Q. So that makes an angle there. P goes here to here. So then now, inscribed angles that intercept the same arc, what do you think can happen with this conjecture? What can you tell me? Inscribed angles, so compare P and Q. What do you think is going to happen? They're going to be congruent. They're going to be the exact same measure. I'll let you get that down. We'll go to investigation 3. Okay, so moving on to investigation 3. Okay, notice what this is, angles inscribed in a semicircle. So let's think about that, in a semicircle. So specifically, I'm just going to pick one of them, and I'm going to go ahead and highlight it. So there's my first angle that's inscribed in a semicircle. So let's think about that. What do you think this measure is going to be? What do you think that measure is going to be? What? 90. Why 90? The reason why it's 90, let's think about that. Okay, the arc that it intercepts out here, remember this is a semicircle. So what would the measure of that big arc be? 180 because it's a semicircle. So since it's 180 degrees, my inside angle right here has to be half of 180. Half of 180 we know is 90. So here you go. Angles inscribed in a semicircle are right angles. So it's really important, I can tell you especially on the homework today, inscribed angles and their intercepted arcs, you need to know the relationship between the two. Got to. Alrighty, next one we're going to talk about is on cyclic quadrilaterals. Now I'm going to warn you, okay? Every other time I've looked at this, it's been an inscribed quadrilateral. I've never heard it referred to as a cyclic quadrilateral. So what you might want to do is you might want to put inscribed in parentheses because that might make a little bit more sense to you, especially if you're going to write this down. Okay? A quadrilateral inscribed in a circle is called a cyclic quadrilateral. So basically what that means, all four vertices are on the circle and the quadrilateral's on the inside. That's where you get the word inscribed. So here are my four vertices. So real quick, we're going to go ahead and look at the opposite angles. Okay? So I'm going to start by looking at this angle here and this angle here. So let's think, first of all, the purple one. That would be this arc right here, correct? The blue one would be this arc here, correct? So what do you know about the sum of the blue and the purple? They're going to be what? They're going to equal 180 because the blue and the purple here total 360. They add together to be 360. So that means that these two angles would be half of that, which would be 180. So let's fill in the blanks here. The blank angles, opposite angles of a cyclic quadrilateral or an inscribed quadrilateral, if that makes sense to you, are what? What word goes there? Supplementary, good. Supplementary, remember, means they total 180. Complementary means they total 90. Lots of info today. We've got one more we're going to look at. Okay. So one more, and then that's it. Hold on. And this is kind of one that isn't going to take us long to go through because it should be pretty straightforward. What we're doing, okay, is we're going to go ahead and take a circle. Notice we've taken a circle here. And imagine I put a ruler on it. And what I've done is I've drawn in a line here, and I've drawn in a line here. What can you conclude about those purple lines?
Chords.
They're what?
Chords.
They're chords. Okay, what else? They're parallel. So they'll never meet, right? So now I want you to compare these arcs. What do you think is going to happen to those arcs? They're going to be the exact same. Because if they're parallel, they're never going to touch. They have to stay the same distance apart. So that means that the blue would be the same. Okay, so parallel lines intercept. Okay, congruent arcs on a circle. And like I said, that's one of those things that should make sense anyway. You should be like, well, yeah. I mean, that's. So now I'm going to give you your assignment, and then we're going to look at one example to make sure that we get a good start on things. So this is your assignment, pages 327, 328, 1 through 16. Now, if you work now, you should be able to get it done. And that would be nice to not be able to, not have to take home your math. I'm going to go ahead and in class, we're going to go over number 6. Okay, 1 through 16. So I'm going to quickly draw number 6 right now. Okay, just for. So if you want to go ahead and look in your book at number 6. Now obviously this isn't going to be drawn to scale since I'm doing this freehand. We'll see how it goes. We'll see how close I can get it. Okay, so this is number 6 from your book, pages 327, 328. And we need to find F and G. So this is what you're going to need to do. Let's look at what we're given. First of all, do I know anything right away? What is? This is 90 degrees, right? Okay, what else do I know? What about measure F? F has to be what? 90. The reason why F has to be 90 degrees, even though it doesn't look like it in my diagram, your diagram in the book's probably a little better. Remember opposite angles. So opposite angles would be this angle here and this angle here. They're supplementary. They have to total 180. So if you already have 90, this other one has to be 90 as well. Yep. So this one is 75, right? So what would this one be down here? Now remember, they're supplementary. What would this one be? 105. Okay, 105 degrees. Now, last but not least, I have to find G. So G is the distance right here. And if I look, I don't have an intercepted angle. I don't have a line from here to here, okay, and from here to here. I have one of the two, but not both. So I can't just say it's half of 1, okay? So my next option is to sit there and look at what else I'm given in the problem. They gave me that 110 and I haven't used it yet, correct? Notice here you see you've got a 110 and they haven't used it at all. So let me think, why did they give me that 110? Let's look at this. Do you see that? Okay. And then if I look at this big arc, let's think about that. I have 105 degrees here, right? So what would this big arc have to equal? 105. What does this one have to equal out here? Has to equal 210. Remember, it's double. You have to file that away to memory. Okay, you have to file the relationship here because you are going to use it a ton. So since this big arc is 210, what must G have to equal? 100. For those of you wondering why, you've already got 110 right here. So the additional amount you need to get to be 210 is 100. And there you go. That's what F and G is. But you're going to have to use those inscribed angles a ton. So 1 through 16. You should be able to get those done. If you have any questions, please ask. And that will be due Monday, okay, along with section 6.2.